All right, so here in this video, I want to show you kind of the gist for what logarithms are. All right, logarithms are going to be able, they're going to give us a way of expressing an exponential, expression a different way. So instead of saying 2 to the fourth power is equal to 16, we have this other notation over here. All right, and it's just another way of saying the same thing, really. So instead of saying, 2 times 2 times 2 times 2 is equal to 16, we say uh, if 2 is our base and 16 is our answer, what was the exponent? That's kind of the way that you would. That's one way you could think of it. Or how many times would I have to multiply 2 by itself in order to get 16? And the answer to that is 4 times. All right, so it's just a kind of a rearrangement, a rearrangement of the numbers. But notice here, 2 has always been our base. If you remember that for like 7th or 8th grade, and 4 is the exponent. Well, the way that you would say this expression over here on the right is you would say log base 2 of 16 is equal to 4. All right, and so the base that's like the only thing that's consistent among this. But instead of you having the base and the exponent and you finding the answer, it's like they're giving you the base and the answer, and you have to find the exponent. All right. So this is the little formula for it. Now this is how you can rearrange the terms. So the base, that'll always be your little part right here, and then the A and the C are kind of switching positions. Is what's happening. So let me go ahead and just through a couple of examples. I'm going to give you an exponential expression, and we're going to write it in logarithmic form, right? In logarithm form. All right. So I'm going to start with log. It's going to be base 8, right? 8's my base, and then of 64. And so what this expression means is uh, if 8 is my base and 64 is my answer, it's saying how many of these 8s do I have to multiply by itself to get 64, right? And that's going to be 2. 8 to the second power is equal to 64. For 5 to the third equals 125. All right, log. My base would be a 5. 125 is my answer. So I'm saying 5 multiplied by itself, how many times would give me 125? And the answer to that is 3. All right. So 5 to what exponent will give me 125? And then this one right here is kind of a funky one. This one's involving those fractional exponents. So remember, 9 to the 1/2 just means the square root of 9. So that's what's going on here. I'm doing the square root of 9 is equal to 3. But now I'm going to write it in logarithmic form. All right, so it's going to be log base 9. So I'm saying 9 to what power? All right, 9 to what power is going to give me a 3? And the answer to that is 1/2. So 9 to this power is going to equal 3. 5 to the third power is going to equal 125. Okay, so it's another way of writing an exponential expression. They come up quite a bit as far as solving exponential equations, which we haven't gotten to. You haven't gotten to do those yet. So what I'm going to do now is look at just evaluating a logarithmic expression. Okay, so you might already have the hang of this, but what you can do is try to relate it, kind of try to rewrite it in this form over here, in exponential form. So 5 is my base, so 5 is going to be like my b. So I could say 5, and then it's going to be to what power, 5 to what power is going to equal my answer. 5 to what power is going to equal 25? And that's going to be a 2. All right, so we say log base 5 of 25 is equal to 2. And that's the same as saying 5 to the second power is equal to 25. All right, log base 3 of 243. This means 3 to what power will equal 343. So you have to ask, how many times do I have to multiply 3 by itself in order to get 343? All right, so I'm going to do 3 times 3 times 3 times 3. All right, that gives me 81 if I do it 4 times. If I do it 5 times, one extra, I get 243. Oh, wait, this was 343, wasn't it? Oh, my bad. I just wrote down the wrong number, didn't I? There we go. It's 243. There we go. So log base 3 of 243 is equal to 5, and that's because 3 to the 5th power is equal to 243. Got it. All right, let's look here at a couple of funny cases here. So log base 7 of 1. So what this is saying is 7 is my base. I'm looking for the exponent so that whenever I evaluate this, I get a 1. So 7 to what power will equal 1? All right, this is going to be 0. And this is actually true for all numbers. 7, well, I say all numbers, a lot of numbers. 7 to the 0 is equal to 1. All right, any number raised to the 0 power will equal 1. All right, so if I look at 6 to the 0, that's equal to 1. If I look at even decimals, so like 0.3 raised to the 0 power, that's equal to 1. Right. So the same thing's going to end up happening here. I've got 1/2 as my base. So I'm looking at 1/2 to what power will end up equaling 1. And that's going to be a 0. So as long as your base is, as long as it's not, I got there's a couple of special examples, but for most cases, as long as your base is a normal number, if your input here is a 1, then the answer to that's going to be 0. So log base anything of 1 will be 0. All right. Here we got a log where the base and the answer here are the same. So the way that I would rewrite this is, so 6 is my base, and I'm looking for the exponent, and I'm wanting the answer to be 6. So 6 to what power will equal 6? And that's a 1. Yeah. How many times do you have to multiply 6 by itself? Well, how many 6s do you have to have in order to get 6? Just one of them. All right. And so actually, this will hold true for all statements. So if you have log base 7 of 7, that will also equal 1. Or log base x of x, that will also equal 1. Because what you're saying is x is my base and x is my answer. All right, so the exponent in order for this to make sense would have to be a 1 there. All right, sometimes they're going to give you an expression where there's no base written here. Now, if that's the case, this is called the common log, right? And what we assume here, we assume it's a base 10. All right, this is such a common logarithm because we use base 10 arithmetic that they write as log, like on your calculator here. They just call it the regular log, and that means log base 10. So for this expression, I would be saying 10 is my base. 10 to what power will equal 100? Well, that's going to be a 2. 10 times 10 is equal to 100. All right, here, same idea. 10 is my base. So I'm saying 10 is my base. what does my exponent have to be in order for my answer to be 0.001? Well, the issue here is that my answer is smaller than my base. So what this is going to be is my exponent's going to have to be negative. What negatives do, instead of multiplying it by 10 over and over, you're actually dividing by 10 over and over. And I believe here it's going to be a negative 3. So if I do 10 to the negative third power, yep, that gives me 0.001. So it's like I'm moving the decimal to the left 3 times. So log base 10 of this answer is negative 3. Okay. And I think that might be all we need for this one.